there is a way of thinking about deriving inverse functions using implicit differentiation. There is a way. I'm going to show you that way. The problem is the AP guys like to force your hand. The AP guys like to force your hand. Kind of like you guys have come up against, and especially if you've been coming into my room for extra stamps. Ooh, we're almost at the end of October. This week is the last required week on your stamp sheet. Next week is a grace week. You can get a stamp to fill in any past stamps. But then we're turning in at the end of next week, we're turning in the stamp sheets. If some of you are behind, come on in. I have plenty of practice problems. Or maybe you have questions on things. Tomorrow you're going to get back in Chapter 2A tests. I need my TAs to help me score them today, but then you're getting them back tomorrow. Maybe you'll have questions on corrections. You can come in and ask me, etc. So all good things, all good things. In the sense of you guys getting your stamps, you can get some clarification on things that maybe you're lacking on. But anyway, stamp sheets, I just wanted to do a quick little, hey, P.S. You're getting a new stamp sheet at the beginning of next week for November and December. But anyway, coming back. How do I get on stamp sheets? No idea. You guys know, coming in and asking me questions, you guys know that the AP likes to force your hands. Because sometimes they don't give you functions. They only give you clues. And so you have to use preset rules in order to solve. For instance, if they were to give you something like, and I'm not going to put it directly on the notes, you guys are still writing them down, getting them ready. But what if they were to say something like h of x is equal to 5f of x, g of x. Find, and they say something like h is a differentiable function, blah, blah, blah. Find h prime of 2. If that was all they gave you, would that be enough information? What are you missing? Well, you remember, you have h prime of 2, which means find, right, h prime of x when x is 2. But what don't you have? Okay, we have a table. We don't have listed clues. And more than that, we don't have functions. If we don't have functions f and g, how can we take a derivative? Oh, well, wait a minute. We actually can't take a derivative. We just can't do anything else without giving clues. They might give you a table. They might give you a graph. They might give you like these listed points that seem really random. They'll give you clues somewhere. So that's the entire question. But how would you start doing this question? You don't even need the clues to start. Actually, what are you supposed to do to clues at the beginning? Disregard. Ignore the clues. They're not helpful until the end. So the reason I didn't even worry about clues is because you don't need them yet. What's the very first thing you would need to do to this to get towards this? Yeah, how? Good, good, good. What rule? Product rule. You need product rule, right? Not chain rule because it's a times. What would you guys do, just real quick? I'm still learning how your brains work. Would you group the 5 in with the f, or would you leave him on the outside? Okay, yeah, I thought period 1 groups him. Period 6 seems to leave him on the outside. I guess they're pretty confident they won't kill seals. Anyway, so we have second, d first, plus first, d second. If you guys just memorized how the rule worked, but you never actually memorized the outright rule, this problem would be impossible to you. If you didn't know g times f prime, well, 5f prime technically, plus 5f times g prime, if you didn't have a way to write the rule, you'd be totally stuck, you'd be totally lost. You don't know who f is, you don't know who g is, you would just kind of crumble and fall and guess a number, or guess an answer. That's what's going on in this section also, in that there's going to be problems. Usually there are problems where you have to know a certain rule. So the implicit differentiation, even though it's an option and you guys can use it in homework, the AP guys are going to make it so that you can't use it once you actually get to the AP. So anyway, to get us even towards the rule kind of like on the board, the rule that you could use if you weren't given all the information, you were only given clues. We're going to come back to this one in just a second. In order to find it, we actually start with a tangent line. Guys, please tell me you recognize this. What is this? Point slope form. Good. Y minus, y minus who? Ah, nice. Usually we plug in y minus f of a, right? equals f prime of a, needs to be at a point, at a number, can't be f prime of x, times x minus, good, that's just our forever card, right? Y minus y1 equals m times x minus x1. Y minus f of a is equal to f prime of a times x minus a. Okay, that's for an original. Oh, I didn't know I put that there. That's for an original function. The one thing that I'm changing is who is f of a in this problem? Yeah, f of a is equal to b. So I put y minus b equals f prime of a times x minus a. The only thing I changed is there is a point AB, so I just went ahead and plugged in the b for the y1 spot. Okay, here's the dealio. This is for an original equation. This is for a tangent line to f of x at a point. Now, how could we find the equation of the tangent line that corresponds to this of the inverse function? Yeah, switch to x and y. It's perfect. So go ahead and, I know it says it there, but you guys also realize for inverses, we always switch the x and y, right? Okay, so switch the x and y. And what I want you to do, switch the x and y, get y by itself. Switch the x and y, get y by itself. Okay? I'm going to do that too. Switch the x and y, get y by itself. Hold on, pause. Do you realize when you switch the x and a, now we have to the inverse, because we're talking about the inverse now, we switch the x and y, at, is the point still a comma b? Why would it be b comma a? What happens with inverses? And then look, who's next to the x now? B. And who's next to the y now? So it is still y minus y1 and x minus x1, but everything got switched. So what was originally 2f of x at, not just any point, let me go ahead and put the AB, at AB, is now to the inverse at BA. Ooh, that's important. That's important. Okay, now rearrange it. If we rearrange it, we don't want the f prime of a to be next to the y. He's supposed to be over here, f prime of a. Now I'm going to write it in a way that you guys might not have thought of doing. But I'm going to do y minus a is equal to, can anybody see what should go in the slope spot? Yes. 1 over f prime of a. Is this still an equation of a tangent line? Yeah. Does this still have y minus y1 equals m times x minus x1? Yeah. Who's in the x1 spot? B. Oh, that makes sense. It switched. What's in the y1 spot? A. Oh, that makes sense. It switched. What's in the m spot? Yeah. But question, who is the m of a tangent line of a function? Isn't that the derivative? So guess what? Just by switching x and y and rearranging, we just figured out who f inverse prime of, ooh, okay, this is where it gets tricky. But so far, do you guys see the notation? The derivative of f inverse, there's no other way of doing it. I'm sorry, it's gross, unless you put a ddx in front. But f inverse prime, so the derivative of the inverse, here's what's missing. Not times, what's missing is at. What's missing is the at. This is the slope. It's the slope of the point at BA. What would be the x value where the derivative of the inverse is being taken? Oh, everyone thinks A. And I get why you think A. Because who was the x up here? Who was the x up here? But that's not true for the inverse. I know that A is plugged in, because it corresponds to the guy up here. It does correspond. It is related. It's not the same slope because it's 1 over. But it does correspond. But the problem is the x is no longer A. Who's the x? B. The idea isn't hard. The slope corresponds to, well, the corresponding point, 1 over f prime of, here's where it gets tricky. To find the derivative of the inverse at b, I need to do 1 over the derivative of the original at A, because I need the x of the original plugged into the derivative to correspond to the x of the inverse. So this right here, these two letters being different, is where it gets tricky. Here's the derivative rule. The derivative of inverses. Given f is an original and f inverse of A is equal to B, which also corresponds to, I'm going to put a little or, and I want you guys to actually put it as well, or f of B equals A. You know what? I'm going to change this wording. Last year it got confusing, and I think it's because I started switching my letters. The reason I did is in this example, we started with the original, so A was my X, B was my Y, and then it switched. Over here, I'm like, we're starting with the inverse. Okay, let me just rearrange this just a little bit. I'm going to go ahead and make this a B. I think it's going to make things a little bit clearer. Okay, let's see if this works. Or f of A equals B. Now it's awkward. That's no fun. Let's do this. And let's do this. There we go. And let's do this. This will keep it in line with our original example, and I think that'll help just a little bit. For some of you, it might be helpful. Actually, I might just do this. No, let's undo. I know, sorry guys. The reason I'm spending so much time on this is because last year there was definitely some confusion with this topic. I mean, there always kind of is, but it's an easy topic. It's really not a hard one, which is why, anyway, which is why I want to make it a little bit simpler for you guys. Yes, it's going to be a forever card. Yes, it's coming. Just hold on. Okay. Marker. Some of you do okay with function notation, and some of you, just to be honest, kind of suck at it. So, hold on. I want you guys to, for this one, write down f inverse has the point BA, and f has the point AB. They mean the exact same thing. F inverse of B equals A. B is the X, A is the Y. F of A equals B. A is the X, B is the Y. I know, I know. Maybe for some of you, you're like, well, that's easy. We should know that. Okay, stop. It's really hard for some people. Or you're like, oh, psh, I know that. Great, write it down. If you're trying to find the derivative of the inverse at B, ooh, his X is a Y of the original. So I need 1 over prime of A. Okay? Technically, fairly commonly, if you wanted to write yourself a little note as far as preparing for AP questions, they sometimes do something like G is the inverse. Sometimes they put a little G in there. They name it something else. So then we could do something like G of B is equal to, and we could say G, which is F inverse, has the point. So then we could say something like G prime of B is equal to. If you want to add in that extra, sometimes they say F is the original, G is the inverse. Sometimes they like to do that. So then you could say, hey, G of is the inverse of, so G, like F inverse has the point, so G prime is F inverse prime of B. I don't know. For some of you, you might want to go ahead and write that down just because of the AP guys. But this is going to be our forever card. Oh my goodness, forever cards, that's a thing. We haven't done that in a while, huh? Implicit differentiation, there was no forever card because it's more of just an idea that, oh yeah, you take d dx at both sides. But this is a new rule and we do need to get them down. I think we're on, oh guys, help me, I'm sorry, forever card 15? Does that sound right? I was trying to think the last card that we had. It would have been at the very, this is 16? Thank you, thank you. I forgot where our last forever quiz ended. Okay, so with this, what if I was to give you the following? Okay. What if I was to give you the following? Here's exactly what I need you to see. They said A, but wait a minute, the forever card says B. Why? Because this is really a Y of the original. Oh, tricky, 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 tricky. So we're going to go ahead and say B instead. In calculus, as long as you establish sort of little statement, kind of like let H equal delta X or delta X equal H. As long as you establish, hey, I'm changing this because I don't like it, it's totally fine. You can name it whatever you want. Okay. So, by you making it B, it already is like ding, 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 ding. Remember, this isn't what you think it is. This isn't the X of the original. This is the Y. Ooh, that's good. That's good. Okay, so how am I going to find F inverse prime of 1/2? I'm going to do 1 over F prime of 1/2. There was a question mark at the end of that. Am I going to plug in 1/2? Do these match? No. Bless you, bless you. Do these match? Remember the struggle? Maybe you need to get a colored pen or a highlighter out and make a big, 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 big deal of it. Do these match? No. Why? Because the X of one is not the X of the other. Ah, stink. But that's okay when you memorize your forever card. Hopefully it helps. The X of one is the Y of the other. So am I going to plug in 1/2? No. So the question should be, who do I plug in? Yeah. That's a good idea. They told me the B of the inverse. So if I was talking about F inverse is point, B is the 1/2. No, wait a minute. The inverse. This is the X of the inverse, right, guys? What does that mean this is of the original? Yeah, that's why I'm having issues. I can't go plug in a Y into a X spot. It's the X of the inverse, it's the Y of the original. Oh, do I have an equation? This isn't one of those where they did give you a clue, but this isn't one of those where we go to a table or go to a graph and try to figure out what's going on. This is one of those where it's like, wait, old-fashioned, plug it in, plug it in. 1/2 is F of X, so what am I actually looking for? Ah, I need to find A. I need to find the X value to plug in, because whoever this guy is who needs to get plugged into the formula. So how do I solve? When is sine 1/2 and inverse trig's coming back? Don't worry, you guys know your unit circle. It's your first forever. Maybe second. Pi over 2 and pi over 2. Wait, what? Pi over 6. Thanks, Rachel. Are we okay? When is sine 1/2? Not in the fourth quadrant. Sine's negative. In the first quadrant, sine's up a little. Right there. 1, 2, 3, 3, 2, 1, all over 2. Square root of 3 over 3, 1 square root of 3. Right? Sine's the first one. 1, pi over 6. 2, square root of 2 over 2. Pi over 4. 3, pi over 3. Right? Okay. Whew. X equals pi over 6. Oh! X equals pi over 6. Ah! So F prime of pi over 6. Whew. All right, we're done. Wait, who's F prime? Oh, we're supposed to actually do that. Just kidding. Who's F prime? Cosine. Of who? Pi over 6. Would it have made sense to do cosine of 1/2? Oh, no, that doesn't make sense. But does it make sense to do cosine of pi over 6? Yeah, it does. Well, if sine is 1/2, what's cosine of pi over 6? Square root of 3 over 2. So 1 over that, 2 over root 3. Or if it was a test, could you have just done 1 over square root of 3 over 2? Or if it was a make it match, could they have done something crazy and rationalized, which almost never happens in calculus, and done that? Sure. Yes, and yes, and yes. Amen, amen, amen. What was weird? Do these match? No. And if they give me the x of the inverse, ooh, what do I have to think of him as? The y of the original. AJ. Yeah. Why? Because they're starting with the inverse. So they're going to call A the first x they give you. But in your mind, you're like, it's a B. Does that make sense? So, ready, set, go. Try to follow the exact same steps. It's a different function, so the math might be different. I'll slowly come behind. But try to follow the exact same steps we just did. And maybe that starts with calling him B. Is anybody finding the algebra to be kind of hard? Like the math to be kind of hard? Yeah. Yeah, this one's harder. But did you get the idea down? I'm not sure if that's good, buddy. Do you have like a migraine? Like, oh. You guys see the dilemma, right? Who do I need to plug in? And who's this? Okay. All right, who got stuck? Now, could you multiply everything by x? Yeah. And you get an x cubed, ultimately minus a 6x minus 4. Are we supposed to factor the cubic polynomial? Okay. Nice thing. Could you factor the cubic? Rachel's smiling. From pre-cal last year, did we learn how to factor cubics? Mm-hmm. Guess what? On any AP question, and on most of the ones in your book, it's going to be a nice answer. Meaning, it's going to be faster to do trial and error than to do the possible rational root theorem with the plus or minus all the factors of and synthetic division every single one or plugging in every single one until you find a 0. It's going to be faster to do trial and error. Like, does 0 work? Nope. Does 1 work? Nope. Does 2 work? 8 minus 2. Aww, what does x equal? 2. How long did that take me? 15 seconds. Did anyone even think to just check? Okay, I know. I've trained you so well to be like, do it by hand, do it by hand, do it by hand. This one, actually, you know what? Do it on the forever card. I'm that serious about it. Okay? I'm that serious about it. If stuck, finding, I'm that serious about it. A, trial and error. Plugging in. If any of you guys have taken an SAT prep course and they say something about maximizing the area of a rectangle, it's always a square. That's what I'm doing here. For the AP questions, I know what's a coming and when it's a coming, if it comes. It hasn't happened lately. Usually they give you the full point and you just have to figure out, kind of like the wording on the forever card, you just have to figure out which one's which and which number actually goes in. That's what they've been doing lately. But if you are stuck finding A, if you have to be finding this guy, trial and error, plug in, it'll always work. Like, I just figured out that x equals what? 2. What if it wasn't 2? What would you have done? 3. -1, -2, -3. One of them is going to work. And your mental math should be fast enough that you don't have to go doing synthetic division. It's going to be nice. Did a miracle occur? No. What did I do? Trial and error. 0 didn't work. It was undefined. 1 didn't work. That's like -3. 2. Ah, it's 6. Dun, 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 dun. 2. 2. What's the derivative of f? Did anybody think of rewriting him? X cubed minus 4x to the negative 1. So wouldn't that bring down the negative 1, which is going to be plus, and it's going to be 4 over x to the negative 2 becomes 1 over x squared. Does that make sense? If you guys had time, you'd be fine with the derivative? Okay, I end up with 3x squared plus 4x negative 2. What am I plugging in? Got it. If it was a long answer, box it, be done. Don't do anything else. Some of you will learn that lesson and get your test back. Anyway, so sad. 1 over 4 and 3 is 12. If you need to make it match, you better keep going. Oh, that's 1. Oh, hey, the final answer is 1/13. Is that okay? Was the algebra hard? Yeah. So what did I do? Trial and error. Go team. So I told you guys there were 2 ways. What's the way that the AP guys are going to maybe, possibly, usually force your hand to do? The formula. And that's our forever card. The formula. That's our forever card. So in the previous example, we had to use the idea of f inverse prime of b is equal to 1 over f prime of a, right? And we ended up on the last example, after we used that, having that crazy algebra stuff, we ended up with 1 over 13. But I did say I would show you the implicit way. And whether you use the formula or you use the in homework, when you're given the functions, it's not like the AP is forcing your hand by giving you the weird, crazy, who are the functions? I don't know. Have fun with the rules, okay? In homework, you're going to have the functions for the most part. You could use implicit, and some of you might prefer this. And here's what implicit does. For the past example, the one that we just did, I'm going to solve it using implicit, but I'm going to zoom in because it's going to get a little rough if you guys can't see. So using implicit, oh, guys, help me out real fast. You would switch the x and y to find the inverse. You could take f. Who was f equal to? X cubed. And we're doing it f inverse prime of 6, right? That's what you're supposed to be finding? Okay. Because of the inverse, we could have just said, hey, switch x and y. X is equal to y cubed minus 4y to the negative 1. Guess what? This is my inverse. And as soon as you switch the x and y, you can say, oh, hey, I don't care that x's and y's are switched. I don't need to get y by itself, which would actually be impossible. Let's just take a derivative. And so you could go ahead and say 1 is equal to 3y squared plus 4y to the negative 2, but don't forget your both of them needed y primes. Question, does this look familiar to any of you guys? If I divide, do I get to the exact same place I was a second ago? But what's different? I have a dy dx instead of my notation, and I'm supposed to be plugging in y's. Y's of who? So if you're going implicitly, you're just going to have to think of it in more of a normal way, in the sense of, oh, hey, plug in the y. Plug in what y? The y of the inverse. What? Oh, I have the x of the inverse. You guys still have to actually do the exact same work. Because remember, what was the x of the original that I had to plug in is the same thing as the y of the inverse. You're just going a different direction this time. Because this time you have to say, uh-oh, let's take the inverse guy and set the x of the inverse equal to 6. If you're looking for the y of the inverse, you're having to plug in the x of the same math. It's literally the same math, just the notation switches, because now you're looking for the y to plug in the y, but it's the y of the inverse, which looks like the x of the original, and it all starts getting crumbling down from there. But what would I have found after trial and error again? 2. What would I have plugged in? 2. Where would that have gone? 2. 2. What's the answer that you get? Same thing, 1 over 13. So some of you might want to play with this idea if you're like, hey, I like that. I like the idea, not having to memorize the formula. But what are the AP guys still going to force your hand with every now and then? The formula. So you can't ignore the forever card. Some of you are like, this is just making my brain hurt, so just stay here. Stay here. But if you're like, wait, I think I can handle sometimes using the formula and sometimes using implicit, this a little bit and see if you like it. We already used the formula. I think that's going to be our warm-up. Let's go ahead and end on this example. We'll have the previous one be our opener for tomorrow. Let's end on this example. Find the inverses derivative at A. Let me put this a little bit differently. Just because they wrote it differently, so they wouldn't have quite given you the directions, dy dx, at the given point. Let's put it that way. They would have written the directions a little differently. Ultimately, you are still, for some ambiguous out there, switch the x and y original function, you are finding the derivative of the inverse because the x's and y's are switched. But in essence, they would say find dy dx. We would take d dx at both sides. That's going to have a dy dx. That's going to have a dy dx. That's a 0. So I'm just going to put a dy dx for both of them. Already factored out. So take d dx at both sides. You have dy dx is equal to you just have to ask yourself, is this a point of the original or a point of the inverse? How could you double check? Couldn't you plug in and see if negative 64 plus 16 plus 62 plus 2, 63 plus 2, I'm trying to do the math backwards in my head, I apologize. Long story short, 15 seconds over, sorry. This is a point of the inverse. And so what would you plug in? Yeah. Plug in y. Anyway, kiddos, we can talk about that. If you see any of that in homework, the implicity stuff, I think most of all you get to choose. Sorry, get out for the extra 45 seconds. I apologize for going over. I didn't hear a noise in the hallway. That was so weird. Anyway, this homework due tomorrow.